All right, let's jump right in. Today, we're tackling a massive, incredibly practical question in this explainer that pretty much every dev team is wrestling with right now. How exactly do we stop API keys, passwords, tokens, and dangerous vulnerabilities from getting shipped right alongside our AI-generated code? I mean, we're seeing AI coding assistants rapidly become just standard infrastructure. But with that incredible speed comes a massive new attack surface. So today, we're not just going to look for one magic tool, because honestly, that doesn't exist. Instead, we're going to build a comprehensive, multi-layered security workflow.
So why are we seeing AI-generated code leak secrets at more than double the normal rate? Well, to really understand the risk, we have to look at a core architectural quirk of the large language models we're all using. Basically, LLMs can't reliably tell the difference between instructions and data. When your AI assistant scans your workspace, your config files, or your environment variables just to get some context, it absorbs everything. And because it doesn't have a strict boundary between this is a command and this is a sensitive credential, it inadvertently hardcodes those secrets directly into its generated outputs. It's an architectural flaw that's essentially the AI equivalent of a SQL injection, just without a simple patch.
And honestly, this flaw is blowing up the threat landscape. GitGuardian just reported a massive 67% jump in secret sprawl year over year. We're talking tens of millions of exposed secrets, and these lead to devastating real-world incidents. Take the 2022 Uber hack. Attackers entirely took over Uber's internal tools just by exploiting admin credentials that were left hard-coded in plain text inside PowerShell scripts. Think about it. If an AI assistant helps you write a script and it autofills a real credential it found lying around in your environment, you are literally one quick commit away from a major breach.
Now, if we look at a really massive empirical study of Hugging Face spaces, the breakdown of what's leaking is wild. A staggering 76% of these leaked keys, they come straight from AI model providers, like your OpenAI or Anthropic tokens. Developers are just hard-coding them to test inference services and then completely forgetting about them. On top of that, 15% of the leaks were access tokens for code hosting platforms like GitHub or GitLab. And the really scary part? Over half of those active code hosting tokens actually had write permissions. So an attacker wouldn't just be reading your code, they could modify it, delete it, or inject backdoors. It exposes teams to massive supply chain attacks.
All right, moving into our first section, code review versus secret scanning. Two very distinct tasks.
You know the old saying, right? You wouldn't use a hammer to drive a screw? Well, you shouldn't use a structural code reviewer to hunt for API keys either. We really need to understand the difference here. AI code review is hunting for structural bugs, insecure logic, and poor code quality. It's looking for things like null pointer exceptions or unescaped output paths that cause cross-site scripting and SQL injections. Secret scanning, on the other hand, is a highly specialized dragnet. It honestly doesn't care about your application logic. It's looking specifically for exposed credentials, strings of text that exactly match the formats of API keys, authentication tokens, and passwords.
So for that first task, AI code review, let's look at a really brilliant example, Alibaba Open Code Review. They recently open-sourced this after using it to catch literally millions of internal defects. They use a hybrid architecture, which is key. See, pure LLM reviewers often hallucinate line numbers, right? Or they get completely distracted. But pure deterministic linters, they totally miss the context. So Alibaba combines both. They use deterministic pipelines for exact line-level precision and combine it with an LLM agent that actually understands the context across your entire repository. This hybrid approach is exactly how you catch deep logical flaws and thread safety issues in AI-generated code, all without drowning your dev team in false positives.
Which brings us to Section 2, pre-commit hooks, your absolute first line of defense.
Right at the developer's laptop, the goal is super simple. Catch the secrets before they ever hit version control. Because once a secret is pushed, even if you delete it a second later, it lives forever in your Git history. Let's compare two heavyweight tools for this pre-commit phase. First up, Gitleaks. Gitleaks acts as a lightning-fast offline regex blocker. It scans your stage changes in literal milliseconds using over 150 patterns. If it spots an AWS key, it instantly aborts the commit. But what if you're working in a massive legacy codebase that's already full of dummy keys and test passwords? That's where Yelp's Detect Secrets really shines. It uses a baseline file. Basically, it scans the repo once, records all the existing noise as a baseline, and then only alerts developers on new secrets. That way your team isn't overwhelmed by 5-year-old historical noise and can focus strictly on the AI-generated code they're committing today.
Now for Section 3, CI/CD and deep verification.
Look, we've all been there. You're in a rush, you throw in a no verify flag, and boom, you've bypassed the local pre-commit hook. That is exactly why we absolutely have to have a mandatory verification layer deeper in the CI/CD pipeline. You need both speed and depth for a mature security posture. So in CI/CD, you might run Gitleaks for a really fast initial pass, but you also need a tool like TruffleHog. While Gitleaks is built for sheer offline speed using regex, TruffleHog operates a little slower because it does something incredible: live verification.
And TruffleHog is a total game changer here, because it solves the biggest headache in secret scanning: alert fatigue. If a regex tool sees password equals change me, it flags it, right? But TruffleHog actually takes that suspected credential and actively tests it. It makes real API calls to the provider, like pinging AWS with a get caller identity request or checking a token against Stripe. If it gets a successful response back, it knows for a fact that the secret is alive and dangerous. This ensures that when an alert actually fires and breaks your build in CI/CD, you know it's a confirmed critical threat, not just the dummy test string.
Next up, Section 4, Continuous Monitoring and Static Analysis.
Because, our job doesn't magically end at deployment. Sometimes secrets get generated in weird ways that evade regex, or they get introduced outside the normal commit flow. For that, platforms like GitHub run continuous secret scanning at scale. And what's really fascinating is how they're using LLMs to slash false positives by over 75%. Instead of just looking at an isolated string, GitHub's context-aware AI actually looks at how that string is being used in the code. Is it just a random UUID, or is it actively being passed into an authentication header or a cloud SDK? By looking at the data flow and the context around it, the AI can confidently say, yes, this string is acting as a secret, catching those complex leaks that standard pattern matching just entirely misses.
And right alongside that continuous secret scanning, you have to run static application security testing, or SAST. Tools like Semgrep, CodeQL, and SonarQube, they essentially treat your code as data. They're continuously querying your pull requests for known insecure code patterns and vulnerabilities. So, while your secret scanners are busy looking for the keys to the vault, your static analysis tools are making sure your AI assistant didn't just leave the windows wide open by writing a function that's vulnerable to SQL injection. All right, bringing it all together in Section 5, the multi-stage security workflow.
Because really, none of these tools work in isolation. To actually secure AI-generated code, you've got to weave all these specialized layers into one seamless pipeline. Let's walk through what that concrete workflow looks like. Step 1, your developer uses an assistant for AI code generation. Step 2, AI code review. Using something like Alibaba's hybrid system, instantly checks for logical bugs. Step 3, secret scanning runs locally at the pre-commit stage with Gitleaks or detect secrets to catch hard-coded keys immediately. Step 4, static analysis kicks in with tools like Semgrep to scan for deeper vulnerabilities. Step 5, automated tests run in your CI/CD pipeline where TruffleHog live verifies that no credentials slip through. Step 6, only after passing all those automated gates does the code finally reach human review. And then, Step 7, secure deployment.
So, I want to leave you with this absolutely vital takeaway. No single tool is a silver bullet. You just can't buy one tool and assume your AI-assisted developers are completely safe. Secure AI development absolutely requires stacking these multiple specialized security layers. You need the lightning speed of pre-commit regex, the context of AI code review, the certainty of live credential verification, and the deep structural checks of static analysis. If you build this layered pipeline, you can actually harness the incredible speed of AI generation without risking your infrastructure. Thanks so much for joining me for this explainer, and honestly, I challenge you to go audit your own CI/CD pipeline today. Which of these layers are you missing?